Uh, Greeting, guys. Uh, Welcome to physical chemistry class, whereby today we are going to solve a question that has to do with the initial concentrations. As you can see in this table, we have the initial concentrations, 5 of them, together with the rates. So the question of the day is that the decomposition of methyl bromide at 573 Kelvin, this is the temperature, was investigated, and the data was recorded as shown in the table below. So by the way, this is the table including the data that were obtained as far as this investigation is concerned. So the question requires us to write the rate law expression and graphically find the order of the reaction and the rate constant. So in other words, there are few things that are expected from us. Firstly is to find the rate law expression. It also has to do with, or this question also has to do with plotting of a graph. As you can see here where it says graphically find the order. So in other words, we are going to find the order through graph means. So without any waste of time, let's now get into the business of the day and try to answer this question. You are more than welcome to pause the video and then work the problem out. After that, you will repause the video and check where you gone wrong or where you go right as far as answering this question is concerned. So now let's start with the answer. This is what we are going to do. The rate law expression for this reaction is going to be V0 is equals to CH3Br P, or to the power P, whereby this P is the order, and then this one just means that we are referring to the initial rates, we're referring to the initial concentration. So if you check, this is the rate law precisely because generally this is the format of the rate law, right? The rate law expression. So now in this case we only have one reactant, which is methyl bromide. That's why we only have the concentration of methyl bromide written here. And then if maybe this now was or this expression was for more than 2 reactant, you know that the rate law was going to account for other reactant and so on and so forth. But this question now, it only have one reactant, which is CH3Br. That's why I wrote it here like this. And then P is the order of the reaction. So in other words, I just decided to use letter P. You can use any letter of your choice, but then it must be at this region here, or at this point here, because that's where we usually write the rate order of the reaction. So now we want to bring this P down here so that it can be easy for us to simplify and solve this question. So in order to do that, we have to introduce logarithmic. So let's introduce log in this equation. If we were to do that, you will find out that log of V0, we introduce log here, we're going to have log V0 is equals to log K, this K, plus, we brought P down, that's why it's going to be plus P log of CH3Br, this one. So in other words, this equation is the same as this one. We just introduce the log on this equation. So from there, let's rearrange this equation so that it can be more like a straight line, because actually this is a straight line equation, by the way. So what I did here is that this is more like our y, this is the gradient, this is the x-axis, and then this is the intercept. So now I just rearrange, I just write this one on the right here, or not on the right but in front of this part here and bring this part on the left. So in other words, these two just swapped the position. So this equation now, it's more like y is equal to mx plus c, whereby we know that this is a straight line equation. And this simply means that your y, or on the y-axis, this log v0 is going to occupy the y-axis part. And then the gradient or the slope of the straight line equation is going to be exactly equal to p. So in other words, if now we calculate and find our slope as let's say the slope is 3, this simply means that even p is going to be 3. So in other words, the slope is exactly the same as p, and we know that p from this rate law expression here is the order of the reaction. So this simply means that the order of the reaction will be found, or when after you calculate the gradient. So in other words, the gradient will be the order, or the slope will be the order of this reaction. And then on the x-axis, we are going to write this part here, log of the concentration of CH3Br. So will be our x-axis. And then the intercept will be this part here, log k will be our intercept. So now, without any waste of time, let's quickly plot now. So we're going to write our plotting table here, whereby we're going to have CH3Br. Oh, sorry, my pen just wrote it in a unfamiliar way here, but I will explain it. So this is what is going on. So this one is exactly this one. So in other words, this is the methyl bromide, or the concentration of methyl bromide, and then from there, this is log 0, like log v0 here is this one. It's your y-axis. So in other words, this part is our x-axis, the top one, and then the underneath part is the y-axis. So from there we can draw the lines so that we can insert our value nicely. The first thing that we'll do, you know that we don't have log of this methyl bromide, but we have this methyl bromide, the concentration. We have their concentration. Here is the list of their concentration. This simply means that at this position here, only this position, we are going to press log of this value, 0.2 here. So when we press log of this value, 0.20, we're going to write it here. So when we do that with a calculator, we found out that log of 0.2 is going to be negative 0.699. So here on this one, we're going to press a calculator, and we'll say log of 0.16. So the answer for that, log of 0.16, this one here, we're going to write it here. So when we do that, actually we first write for the y-axis, because we wrote the one for x-axis, right? So for this y-axis, we said log of this part here, 0.0052. That's what we do to get this value. So to get this one here, as already explained, we just press log of 0.16, and then we'll get this number here. And then for this one down here, we will come and press what, log of 0.0416, this one here. So we'll find the value for this one here, which is going to be negative 2.381. So for this one here on top, again, it's log of 0.12, this 0.12 here. From there, this one underneath here, we are going to press log of 0.0032. Actually, before I even finish this video, you should already see the pattern, or the trend and the procedure that I'm using, in a sense that you can even pause the video and continue and try to answer this question, or the rest of this question, and confirm at a later stage if you get it right. So for this one here, we just press log of this value, we get negative 1,097, And then for this one here, this is the value we're going to write it here. We just press log of 00208 to negative 2.682. And then for this one again, it's log of 0.04. We got this value. For this one here, we are going to write log of 0.00104. So you will realize that we are done with the table now. So what is left is only to plot this graph, whereby this part will be on your y-axis, right, this one, and then this one, or this top part here, will be on the x-axis. So from there, let's delete that part. We are going to plot. We just plotted here. So this is our graph. It's going to look like this, whereby log v0 is this one. It's going to be on our y-axis here, as you can see. So here on the x-axis, it's just that you can't see it well, but you're supposed to write this one here, log of ch3br. So it's supposed to come here, and then it's supposed to come with its units, which are this one. This is the units, mole per liter. So it's supposed to be written underneath here on the x-axis. So from there, after plotting the graph, we can find now the slope. So how do we find the slope? We know that the slope is equal to y2 minus y1 all over x2 minus x1. From there, we are going to pick 2 points that we are going to use. I will just pick the first point and the last point for the purpose of this video. So in other words, I'm going to pick this point, these 2 coordinates here, and obviously also these 2 coordinates here. So in other words, the trick here is that if I decided to make this one my y2, automatically this one should also be x2. If this one is y2, this one should be x2. If this one is y1, this one should be x1. No vice versa. So if I decided to make this one my first coordinate, it means that this one should be my second coordinate. If this one I decided to make it my first coordinate, so this part should be my second coordinate. No vice versa. So for this video, I decided to say this y2, or to write this value for y2 as this one. Obviously, even the x2, as you can see, this x2 its value is this one, and then the minus y1 is this one here, which is this value here on the table, and then the x1, this value here, which is here on the table. So in other words, that is that. So you can see that this is just a direct substitution, whereby I just said y2 minus y1 is this one, y2 minus y1 over x2 minus x1. So that is basically that, and when you press the calculator, this will be equals to 1. What does that mean now? Remember, in the beginning of this video, I mentioned to say the slope or the gradient is exactly the same as the order of the reaction. So this simply means that now, since p, or since 1 is the gradient, then the value of p should be equals to 1, meaning that the order of the reaction it's 1. So in other words, this is the first order reaction. So meaning that the value of p is equals to 1. From there, we can write the rate law expression again this time around. The rate law expression is going to be v0 is equal to k close brackets or square brackets ch3br 0 to the power 1 or to the power p, like that. But we know that that p is exactly equals to 1, this p. So let's rewrite it and include or replace that p with 1. So I just replaced this p. Remember, at the beginning of this video we had the rate law as this one, but since we have worked it out and find that the value of p is equals to 1, I can now just substitute this p with 1 here, or rather still I can even cancel this one and leave it like this, because we know that there is 1 here. We may just not write it mathematically, like that. So now, from there, we are required to find the rate constant. We just found the order, we just graphically do so, we find the rate law expression, but now we are going to find the rate constant, which is the value of k. So I just recopied this expression though, or this one, but I made k subject of the formula. So to find the value of k is very simple. I can just come to the graph here in the graph and pick, let's say, these points. For the purpose of this video, I just pick the first points here. So in other words, instead of this v0, can you see we have v0 here? I will write this value. Instead of v0, I will write 0.0052. And then instead of the concentration of CH3Br, I will write this concentration. So the trick here is that if I choose this value for my V0, then automatically the concentration should always be this one. It's going to be wrong if I decided to choose this rate and then for concentration I pick this one, because this rate only correlates with this one. This one only correlates with this one. This one only correlates with this one. And this one only correlates with this one. And even the last one, this 0.00104, it correlates with this one here. So in other words, if I were to choose this V0, then even the concentration, I must choose this one. So let's do that, and then we're going to have V0 as 0.0052 together with its units, like what I did here. And then from there, the concentration, I choose this one, 0.2 mole per liter. After pressing a calculator, I realized that the answer is going to be 0.026 per hour. So you will realize that mole per liter cancel out with this mole per liter, and the units was per hour. So we have successfully answered the question as expected. And thank you so much for watching this video. I kindly subscribe to this channel. I'm requesting everyone to join this growing family so that we can learn through distance and online learning. Thank you.